Hello and welcome back to another episode of Getting into Good Oxide. Hello and welcome back, Sydney.
Hi, Sebastian.
Feels like not too much time has passed, but of course it's at least a day.
You never know.
You never know. And we are back with the describe implementation. And I think, like looking at this here, we left it. Yeah, we were about to sketch the data structures here. And not too much has happened. The candidates we push. And the next thing, what's the next thing? I think I already brought that here. Next thing could be this block, like literally
Yeah.
kind of the same thing. And for this, we need data associated with the objects. And right now, I don't think we have that. Right now, we pop and we have a commit. And we remember that. And then we check if that commit is associated with a name. And if so, we remember that name with a lot of data, similar to how it probably should be. But then we aren't able to continue here while just having this data. So yeah, what we would need is flags. I think flags is the only thing, just something to keep track of the tags that are in the ancestry or in the future. Yeah, I mean, anyway, that are there associated with that object. And that looks like
this
it.
flags is just a way to, yeah, so you just set it basically, and that's just a way to keep track of how many or what tags have been, and we've seen already basically.
And this flag within, that's just the tag's ID. I think we called it differently as well. We called it tag ID or something, because that's just a way to see, is this tag known or in the ancestry of that object? And if not, then we count it. Then we increase the depth, which really also just is how many commits are in between. Like depth is not really how many commits are not in the ancestry of that tag. This is what it counts. And I don't know if death is a good word. I think we might be finding a better name for that one day. Okay, so yeah, how do you suggest we adjust what goes onto the queue? Here we can do that.
Isn't it about we have to store these other, like what we've seen already, right? That was that the data structure that you were talking about?
Yeah, like only flags we need apparently. Flags is the thing. Flags, OID, flags, yeah. So we just need an object that has an ID, and that's the data and flags. And I think that's it. I wasn't quite sure if that has to be persistent in some way, but for now we can just keep it in our temporary queue here, because these flags will propagate anyway, and that should be fine then. That's my assumption. Yeah, so how should I add that data? Like we need some flag. Yeah.
So you would add it to, I don't really understand where you would add it to, like how we would keep track of it, track of that.
Yeah, I mean, our only way to persist any information right now is that queue. And that's our work queue where we traverse the graph that we used to traverse the graph with. Right now it only has the commit ID. And yeah, we can just
have so you make a new data type out of that basically, that encompasses both the commits and this flag.
Yeah. And that data type can be, I just said, okay, our flags, that's the use size, for the only reason that I want to make sure that stays aligned here. Why does it not? It should pick that up here. Apparently IntelliJ cannot see locally created types, or it's a real thing. No, it does compile, it's just IntelliJ that doesn't get it. Okay, fine. So now I would just make it a tuple here.
Okay, so not an extra type, just yeah. Okay.
I mean, it kind of isn't. Yeah, it's just an unnamed type.
An extra struct, sorry.
No extra struct, because it's really just these two fields, and we can probably just name them accordingly. So this starts out at 0. And it's a flags thing. Ah, now it knows it. Interesting. Look at that. Took it a while. And now we have flags associated with everything we put onto the queue. And that should compile just fine. And it does. Cool. Yeah. And now I think we are able to implement this loop. So wherever the candidate tag is not in the ancestry, we want to increase its depth. So for yeah, how do you call it? Let's call it candidate, because we have this candidate structure here. In candidates, item mat, we want to change it, and we can just filter it by some criterion, which is if the candidate is not something which is
flags.
Yeah, right, the flags, if they should not match our candidate identity bit. And then we can increase the depth of the candidate. Like that. Yeah. And that's this one here. Let's double check. And just check the bit if it's, oh yeah, right. You can't do this because that's not a Boolean. You have to say if that and that is the identity bit.
Yeah, I was a bit confused about that in general, because the bit shift, yeah, what's the output of that? It's a new number, right?
Yes, it's a new number. And yes, in C, it just, if it's 0, it's false, otherwise it's true. And that's, of course, abused all the time. I don't know if it's a feature or a bug, but yeah. It's super interesting, you know, like these simple things, they can still break your neck. And C is just full of these breakneck thingies. And just recently on Hacker News, there was this great post about pointers and how pointers in Rust are not up to the task right just yet, and the suggestion how to make them up to the task. And there I learned something about pointers I just didn't know before. There's so much more about them, and they get safer. That's good, safer even on hardware level. But there's a pointer is not an int. A pointer is not a use size that you can just, you know, use to point at any byte in memory. A pointer by now is actually more than that. There's more data associated with it, and newer hardware has that, and compilers need that information. And if you are able to cast a use size into a pointer, you break the compiler entirely, because it really doesn't know anything about that, about the sanity of that pointer anymore, and then tends to assume the worst and all the optimizations that are possible go out of the window. So that sucks for unsafe code, for unsafe Rust code, for safe Rust code, not an issue. But whenever you go unsafe, it's a major pain to work with pointers right now in Rust. And it's because of this. But yeah, future editions probably will address that. And hopefully I will never have to do unsafe because I always feel... Anyway, I digress. So the, I think that's it. It compiles not. Flags, where is it? But there it is. Why is it not in scope? It's a bit strange because I thought I put it in scope here. So
Should be there.
or am I outside here? I'm outside. Just
See.
off by 1. Okay, fair enough. Cool. And we don't run the code yet. This one test here is still deactivated.
Mm-hmm.
Even though we could possibly run it because there's at least one way of breaking and 2 ways of breaking out of this. And right now it doesn't actually put any more work on the queue. Because the next thing is to, yeah. So this is special here. In libgit 2, this is not done. This is an early exit kind of thing. Mm-hmm. And by the looks of it, we can implement it with what we currently have. Provided we also understand it, which right now I don't so much, even though it says it here, but I usually have trouble understanding why that then means this. But because it's kind of hard to understand exactly what this is, I think what we really want to be able to reasonably run this is at least get some parents here.
Like yeah, that would be the next part for me as well. Just get the iteration going, basically, the traversal, yes. And then we have the basic building blocks.
Yes, agreed. And here, get the commit, put the parents on top, keep the flags that you had before. And oh, there's a first parent option here, which we don't currently implement, but we can just do that, no problem. And commit list insert by date, also interesting. Insert by date, we also don't do yet, but we certainly can. If it's not seen yet. Okay, let's try that. Mm-hmm. So there is this find. Mm-hmm. Hello. I don't get any IntelliSense stuff. It gets an OID and a vec. Do we have a buffer here? No. So the OID is our commit, and the buff is our buffer.
Just reuses that, right? Whenever we find it, just gets overwritten.
Mm-hmm. And that's usually what I do. I always reuse these buffers. Git doesn't do it, or does it somewhere in the object database hidden away, and global and static and all the things you don't want if you want to be fast with threads. So yeah, what does it return? A result that
result.
Yeah, and we just said we return that error right away, so we can just error out of this. And we get a commit iter. Okay.
And that is the structure that parses the commit itself, right? The internal messages and everything.
So with that, we should be able to find the parents with that commit iter for parent in Does it have some utility to get the parents? Doesn't look like it. Let's see, maybe I'm missing it, or commit ref either. Commit ref either. I thought I already added something like it. We can get the tree ID quickly. We can get signatures quickly. We can get the committer quickly. I know what. I implemented this once. Traverse. Commit traverse implements this. And I will just take exactly that code. I don't want to think about how to do it right. Where is it? Here. So just, that's an iterator itself, so we can just go through it and then we check for tokens which are parents. And this already knows parents first, then it breaks out of it. And because the first things in a commit are always the parents, we immediately stop when there is some other token. And just to check that again, git cat file. Yeah. The first is tree though, and then comes one or more parents. Right, see? So here we get the tree once. This is how we just skip over the tree, essentially.
Okay.
And then we start actually iterating through our stuff. Otherwise, you would get here right away. I think this time I'm going to implement it differently. As in, we can just know the tree token and continue when we see it. And just have one loop here. So commit either. It's even named the same. Cool. And if we have a git object commit ref either token tree something. Yep. Then we continue. Otherwise, if there's an error, it naturally aborts. And now we can't reproduce, we can't handle that error, unfortunately. Because our current error type doesn't yet have this possibility. The only error we currently can handle is the one where find doesn't know things, but decode errors we can't do yet.
Not yet.
And that seems like a thing to put into to do. We break out once there is something else coming up, once we're done with the parents. And yeah, here we've got parents with IDs, and that's exactly what we want. That's interesting here. So once this one finds a parent, it immediately queries it. To get the committer date. Now I see. Yeah. Because look at, I think I copied it from the code that sorts by commit date. So it's not a topo sort, it's a topo plus sort by commit date. This is why it does another access.
And do we need this? I mean, in Git, they they insert by date as well.
So commit list insert by date. Yeah, so their items do have a date And it's descending, so the most recent ones come first. Yeah, most recent one first. Yeah, it's a linked list by the look of it. Right now we do have a vector. Yeah, I would just use a vector. And we can probably sort this, keep this sorted, use a binary search to just keep stuff sorted by date. And yeah, just insert by date. That could work, I guess. What's your thoughts?
Yeah, I was just thinking if there's a way, because you do have to decode it twice then, right? Basically, when you look it up right here and then in the next step again, unless there's some sort of caching, but we probably won't do that.
That's the thing. That's the beauty of just having a closure. If there is a cache, find has to do it, and find is an fn mut, so it can change its state. This basically means it can keep track of stuff. It can have a cache.
Okay, so you would, okay, I see. So you would build that cache into the function that you're passing in, basically, and whenever we get the same commit ID, we can just reuse what we already parsed.
Yeah.
Okay, that's pretty cool. So that, but that would be an easy optimization for later as well. Like we don't have to do that now. We can just focus on the on the actual meat.
Yes. And this is going to be a real advantage to set up an object cache, but the one who calls, you know, this would be part of the documentation. The one who calls should set up an object cache of some sort. And good that every database handle, ODB handle is a cache, and you can just turn on object caching, and then the whole object will be cached based by ID. So these double lookups can work fine, and you can make it just small enough to hold a couple of objects because you don't need that much necessarily. You know, 500 kilobyte or so will already do the job for probably most graphs. Of course, depending on file sizes and so on, but it's okay. Okay, ID gives us the parent object as ref iter. Oh yeah, we can probably just look what this one does here. It kind of tiptoes around. That's interesting. It just ignores if there is no parent, because this returns an option otherwise, but we really want the parent, and that just gives us a ref iter. And it does have a committer. Okay, cool. So we are able to do this. Think quickly here. Then we don't need that stuff. We can just copy this. So now that's the potential committer date. Committer should always exist. And with that, you have a committer date. I don't know what to do. Like, do they know what to do if there is no date? Not really. I'd say we work with a null here if necessary. Then there is no date, but then there's at least some sort order to these. I wouldn't want to deal with this. I would just assume, you know, Git does it the same. If there is no date, which they kind of decode here, I'm pretty sure they either error somewhere or they, I don't know where that is decoded and what they do. Maybe they just die before that is null, you know? So I don't know, that's probably something to also put with the to do here. Just to be as correct as Git. Because I think this should always have something there. If it decodes, there should be a committer date. But let's see what Git does and then just be like that, I guess.
Yeah, I mean, I just wonder what it actually means to bring these into sorted, or like into, like insert these sorted. And what happens if they're processed not sorted? Does it really matter?
True. I think
I don't think it does.
I think it matters if your revision listing thing that you're emulating is sorted by date, because you are just like this. You basically do the same algorithm that you get with reflist, like this glola, and I think this by default is sorted by date or something, and this is why they do it too. So they want to traverse just like that. That's what I understand anyway. This is why they do it. So our queue now becomes, I think now we need a linked list to be able to do these. Like, can I do a binary search on a vectag? Because it's kind of a queue, isn't it? But maybe I can. Yeah, I can do a binary search. Okay, good then. Binary search by... Yeah, it's just by date, nothing else. I'm always forgetting what is what. So that just gives one thing and returns an ordering. But we need two things. Search by key. To look that up again. And search by key is just a binary search and we give it some date, right? So we want to find the insertion point for if things are sorted by date. And this is whatever is in the, whatever we want to compare. But what does F do then? That returns the key, right? So this probably means that we're running out of time. Under pressure. That we need some more data here, huh? We need the time.
Yeah, so okay, we're not going to look that up on the fly, but we're going to store it with the actual object, right?
Yeah, because this is the only source of data that we have here is what we keep sorted based on the thing. And yeah, I think that has to be realistically, that has to be for the next time. Probably won't happen just now given the circumstances. So yeah, thanks everyone for watching and I hope to see you again tomorrow. Bye bye.
Bye bye.